If this signal from space is confirmed, the cosmos is not what we thought. It begins with a signal that should not exist, not because it is weak or distant, but because it is too precise, too clean, too deliberate for a universe that rarely repeats itself with such discipline. Somewhere, deep in the silence between stars, a telescope captures a pattern that refuses to behave like anything we have ever seen before. Inside a control room, the glow of monitors reflects on faces that were expecting noise, randomness, the familiar chaos of the cosmos. Instead, they see repetition, identical intervals, a rhythm that feels almost intentional. No one speaks at first, because when something like this appears, the most dangerous reaction is excitement. The first instinct is doubt. They run the data again and again. Different instruments, different filters, different teams, but the signal remains unchanged. Not drifting, not fading, not correcting itself like an error would. It stays exactly where it is, as if it is not just being detected, but maintained. This is where the discomfort begins, because the universe we thought we understood does not behave like this. Stars explode, pulsars spin, black holes distort everything around them. Even the most extreme phenomena still follow rules, predictable, measurable, explainable rules. But this signal does not bend to those expectations. And when something refuses to follow the rules, there are only two possibilities. Either we have misunderstood the phenomenon, or we have misunderstood the rules themselves. That is the moment everything changes. Because if this signal is real, then it is not just another discovery waiting to be explained. It is a fracture in our understanding, a quiet interruption in the story we have been telling ourselves about the universe for centuries. And the most unsettling part is not what the signal is, it is what it implies. Because if this is real, then the universe just broke its own rules. The illusion of understanding, what we thought was true. For a long time, we believed we had begun to understand the universe. Not completely, not perfectly, but enough to feel anchored in something stable. We traced the paths of planets across the sky and realized they moved with precision, not randomness. We studied the light of distant stars and discovered that even across unimaginable distances, their signatures carried consistent information. We measured the expansion of space itself and learned that the cosmos was not static, but evolving, stretching in a way that could be described, predicted, and trusted. That trust became the quiet foundation of modern science. Every observation reinforced the idea that beneath the complexity of the universe, there existed an order. Gravity pulled matter together. Light traveled at a constant speed. Energy transformed, but it was never lost. These were not just facts. They were the rules that gave structure to reality. They allowed us to build models that connected the smallest particles to the largest galaxies, forming a coherent picture where everything had its place. There was a certain comfort in that coherence. Even the most violent and chaotic events, exploding stars, collapsing cores, the immense gravity of black holes, unfolded within boundaries that mathematics could describe with astonishing clarity. Nothing was truly arbitrary. Every phenomenon, no matter how extreme, could be traced back to underlying principles that remained consistent across the entire universe. And when something did not fit, when an observation seemed to contradict expectations, the response was never to doubt the rules themselves. Instead, we assumed we were missing something, a variable not yet discovered, a detail not yet measured, a refinement that would eventually bring the anomaly back into alignment with everything else we knew. The system, we believed, was sound. It was our understanding that needed adjustment. Over time, this belief became so deeply embedded that it was no longer questioned. It faded into the background of every experiment, every equation, every conclusion. The universe was vast, mysterious, and often surprising, but it was never fundamentally unpredictable. There was always an explanation waiting to be found, even if it remained just out of reach. This is what made the signal so unsettling, because it does not behave like something that is waiting to be understood. It behaves like something that does not belong within the framework at all. Not in the dramatic sense of breaking a single rule, but in a quieter, more disturbing way. It moves outside the patterns we rely on. It refuses to align, not violently, but consistently, as if the system itself is not being violated, but bypassed. That distinction changes everything, Because if a phenomenon breaks a rule, we search for the reason. But if it exists outside the rules entirely, then the question becomes far more difficult to face. It is no longer about fixing an equation or refining a theory. It is about confronting the possibility that the structure we trust is incomplete in a way we never anticipated. What if the universe is not a closed system of perfectly consistent laws, but something more layered, more complex than our current models can capture? What if what we call reality is only a surface, a stable pattern that holds true most of the time, but not all of it? That idea introduces a kind of tension that science is not used to holding for long, because it suggests that certainty itself may be conditional, that the rules we depend on might not be universal in the way we assume, but local, limited, or even contextual. And if that is true, then the signal is not just an anomaly. It is a message, not in the sense of intention, but in the sense of revelation. It reveals a boundary we did not know existed, a limit to our understanding that was invisible until now. The most difficult part is not accepting that we might be wrong. Science has always evolved by correcting itself. The difficult part is realizing that we may have been wrong in a way that reshapes the foundation, not just the details. Because once that possibility enters the conversation, it cannot be contained. It spreads through every assumption we have made about the universe, quietly asking the same question again and again. What if the system works perfectly until something appears that was never meant to be part of it? The signal, not what it is, but why it's wrong. The first instinct is always the same. Identify it, classify it, name it, turn the unknown into something familiar. But this signal resists that process in a way that feels almost deliberate, not because it is complex, but because it is too simple in the wrong way. At first glance, it appears clean. That is the problem. The universe does not produce perfect signals, not naturally. Every known cosmic source carries noise, distortion, interference. Pulsars, for example, can emit astonishingly regular pulses, but even they drift over time. Their rhythm is not absolute. It is shaped by rotation, decay, environment. Nothing remains perfectly stable, not even the most predictable objects in the cosmos. But this signal does. Its intervals do not stretch or compress. Its structure does not degrade. It repeats with a precision that does not weaken, as if it exists outside the gradual erosion that defines every known physical process. And that is where the discomfort deepens. Because what we are seeing is not just repetition, it is consistency without a visible cause. Scientists begin to compare it to everything they know. Could it be a pulsar behaving in an unknown way? A rotating neutron star with properties we have not yet observed? A new kind of astrophysical object? Each possibility is tested, not with speculation, but with data. Frequencies are analyzed, background radiation is filtered. Known interference sources are eliminated one by one, and yet the signal does not adjust to fit any of these explanations. It remains exactly what it is. There is a subtle but critical difference between something we do not understand and something that does not align with understanding at all. Most mysteries in science exist within the boundaries of expectation. They are puzzles waiting to be solved. This is different. This feels like a piece that belongs to another puzzle entirely. Even its clarity becomes suspicious. In a universe filled with turbulence, gravity wells, magnetic storms, and vast distances that distort everything that travels through them, signals arrive altered. They carry scars from their journey, but this one arrives intact, as if nothing has interfered with it, or worse, as if it has been preserved. That possibility introduces a question that is difficult to ignore. How does something travel across the universe without being changed by it? The deeper the analysis goes, the less the signal behaves like a natural phenomenon, and the more it begins to look like a contradiction. Not loud, not dramatic, but persistent. Quietly refusing to degrade, refusing to drift, refusing to become what every other signal eventually becomes. And that is what makes it wrong. Not because it is impossible in an obvious way, but because it violates expectations in a way that is too consistent to dismiss. It does not break one rule. It avoids many of them at once. It exists in a space where known explanations begin to overlap and cancel each other out, leaving nothing solid to stand on. At this point, the question is no longer about identification. It becomes something far more unsettling. If this signal is not behaving like anything we know, then we are not just observing something new. We are observing something that does not seem to belong to the same system of behavior we have spent centuries trying to understand. And when something appears that does not belong, the natural response is resistance, because accepting it would mean taking the next step, and that step leads into a place where explanation begins to fail. The first reaction: denial inside science. When reality presents something that does not fit, the first response is not curiosity, it is resistance. Inside the control rooms, the atmosphere changes, not with excitement, but with restraint. No one rushes to conclusions, no one announces a discovery. Because in science, the most dangerous mistake is to believe too quickly, especially when the data feels too perfect, too clean, too far outside the boundaries of expectation. So, the process begins. The instruments are questioned before the signal is. Calibration logs are reviewed. Sensors are tested again, then tested differently. Entire systems are shut down and restarted, not out of panic, but out of discipline. If something appears impossible, the assumption is not that the universe has changed. The assumption is that something, somewhere, has failed. Independent teams are brought in. Different observatories point their own equipment toward the same region of space. If the signal is real, it must be observable beyond a single system. If it disappears under different conditions, then it was never there to begin with. But it does not disappear. It persists. And that persistence creates a quiet tension that is difficult to describe. Because now the anomaly is no longer isolated. It has crossed a threshold. It has moved from a possible error into a shared observation. And shared observations are harder to dismiss. Still, denial does not vanish. It evolves. New explanations are proposed, not to understand the signal, but to contain it within something familiar. Perhaps it is an unknown form of interference, perhaps a rare atmospheric distortion, perhaps an artifact of data processing, subtle enough to evade detection. Each possibility is explored carefully, methodically, with the full weight of scientific rigor. And one by one, they fall apart. Not dramatically, not all at once, but steadily. Each test removes another layer of doubt, not by proving what the signal is, but by proving what it is not. It is not local interference. It is not a malfunction. It is not a known astrophysical source behaving unusually. It remains. At this point, something shifts. The conversation changes, but not openly. No one declares it. No one writes it down in definitive terms. But the tone is different. The questions become more careful. The language becomes more precise. Because the possibility that once felt distant is now close enough to consider. What if the data is correct? That question carries weight, not because it is dramatic, but because of what follows it. If the data is correct, then the anomaly is real. And if the anomaly is real, then the framework used to interpret it may not be sufficient. This is the moment where science becomes uncomfortable with itself. Because the method that has always worked, observation, verification, replication, is now leading toward a conclusion that does not fit within its own expectations. The process is functioning perfectly, the results are consistent, and yet the outcome feels wrong. That contradiction is difficult to hold. Some resist it by tightening the criteria, demanding even more precision, even more confirmation, as if increasing the pressure will force the anomaly to collapse into something familiar. Others begin to explore more cautiously, not accepting the signal as something extraordinary, but no longer dismissing it as error. And in that space between rejection and acceptance, something new begins to form. Not an answer, but a realization. The data is not going away. It does not correct itself. It does not fade into noise. It remains stable, present, and increasingly difficult to ignore. And with every attempt to explain it away, it becomes more defined, not less. That is when the real tension begins. Because the question is no longer whether the signal exists. It is what happens next, if it does. Patterns in the noise. When chaos starts looking intentional. At first, the signal was treated as a single anomaly, a fixed point that refused to behave. But as the data accumulated, something even more unsettling began to emerge. It was not just repeating, it was organizing itself in ways that no one had expected to find. The intervals were measured again, this time not only for consistency, but for structure. Subtle variations appeared, not random, but patterned. Small shifts that did not break the rhythm, yet did not belong to it either. It was as if the signal carried layers, a surface repetition hiding something deeper beneath it. In the natural universe, patterns exist everywhere, but they are rarely perfect. They evolve, drift, degrade. Even the most regular systems, orbital motions, stellar rotations, oscillations of distant objects, show imperfections over time. Noise is not an error, it is a signature of reality itself. But here, the noise begins to behave differently. Instead of disrupting the signal, it aligns with it. What should be interference starts to look structured. What should be decay starts to resemble modulation. The boundary between signal and noise begins to blur, and that is where the discomfort intensifies. Because when randomness starts to look organized, the question changes. It is no longer enough to ask what the signal is. The focus shifts toward how it is behaving, and more importantly, why it is behaving in a way that suggests coherence, where there should be none. Analysts begin to map the variations. Timing sequences are broken down into finer scales. Frequencies are compared across longer observation windows. The deeper they go, the more the signal resists simplification. It does not collapse into randomness, and it does not resolve into something easily defined. It holds its structure. That persistence introduces a dangerous thought, one that is not spoken openly, but begins to circulate in the background of every discussion. Because structure implies process, and process, under certain conditions, begins to resemble intention. No one is ready to say that word. Instead, they use safer language. Regularity, coherence, non-random distribution, terms that describe the behavior without assigning meaning to it. But the implication remains, quietly pressing against the edges of interpretation. What if this is not just a natural pattern we have yet to understand? What if it is something that only appears natural because we are trying to force it into that category? The distinction is subtle, but it changes everything. Because if the signal contains structure that cannot be reduced to known processes, then it is no longer just an anomaly. It becomes a boundary, a point where our definitions begin to fail. And that is where the tension deepens. Because once you allow for the possibility that the signal is not random, you are forced to confront the next question. Not what it means, but what it implies about the nature of the universe itself. Is this an isolated phenomenon, a rare event that will eventually be explained and absorbed into existing models? Or is it a glimpse of something that has always been there, hidden within the noise, waiting for the moment when our instruments became sensitive enough to detect it? That question does not have an easy answer. And the more the signal is studied, the more it resists becoming one. The dangerous question: are we misreading the universe? There is a moment in every scientific investigation when the focus shifts, not outward toward the phenomenon, but inward toward the framework used to interpret it. That moment does not arrive with certainty. It arrives with hesitation, almost reluctantly, as if the mind itself resists turning in that direction. Because to question the data is safe. To question the instruments is expected, but to question the interpretation of reality itself, that is something else entirely. Up to this point, every effort has been directed at understanding the signal within the boundaries of what is already known. The assumption has been clear, even if unspoken. The universe operates according to consistent laws, and any anomaly must eventually fit within them. That belief has guided every calculation, every comparison, every attempt to explain what is being observed. But now, something begins to feel different. The signal does not simply resist explanation, it resists alignment. It does not behave like a problem waiting to be solved. It behaves like a contradiction that remains stable, no matter how many angles it is approached from. And that stability forces a shift in perspective that is difficult to accept. What if the issue is not the signal? What if the issue is how we are trying to understand it? This question introduces a level of uncertainty that extends far beyond a single observation, because it suggests that the models we rely on, the very structures that allow us to interpret the universe, may not be as complete as we believe. Not wrong in an obvious way, but limited in ways that have never been fully exposed until now. For centuries, science has progressed by expanding its models, adding new variables, refining existing ones, building a more accurate picture piece by piece, but always within a consistent framework. The laws of physics have been treated as universal, applying equally across space and time, from the smallest particles to the largest cosmic structures. The signal challenges that assumption without directly breaking it. It exists in a space where the laws still appear to function, but not fully, where predictions still hold, but not completely. It is not an obvious violation. It is a subtle misalignment, one that cannot be corrected by simply adjusting a parameter or introducing a new equation. And that is what makes it dangerous, because it suggests that the problem is not incomplete knowledge within a correct system. It suggests that the system itself may not be sufficient to describe everything that exists within it. That realization does not come easily. There is a natural resistance to it, not out of stubbornness, but out of necessity. Science depends on stability. It depends on the idea that the universe can be understood through consistent principles. If that foundation begins to shift, even slightly, then every conclusion built upon it must be re-examined. And yet, the data continues to point in that direction. The signal remains consistent, but our interpretations do not. Each attempt to fit it into existing models reveals new inconsistencies, not within the signal, but within the models themselves. Small gaps that were once invisible now become more apparent, not because they have changed, but because something has exposed them. It is like looking at a familiar structure under a different light and suddenly noticing the cracks. The question that emerges from this is not comfortable. Are we observing something that does not follow the rules, or are we observing the limits of the rules we have created? The difference between those two possibilities is profound. If the signal is an exception, then it can eventually be explained. But if it is a reflection of a deeper reality that our current understanding cannot fully capture, then it represents something far more significant. It becomes a turning point. Because once we consider that possibility, even briefly, it changes the way every future observation will be approached. It introduces a level of uncertainty that cannot be easily contained. It forces us to look not just at what we see, but at how we see it. And once that shift happens, there is no simple way to return to the previous certainty, because the signal is no longer just an anomaly, it is a question directed at us. Beyond natural explanations, when physics runs out of language, there comes a point when every familiar explanation has been tested, stretched, and quietly set aside, not because it was disproven in a dramatic way, but because it no longer holds together under closer inspection. The signal does not collapse into a known category. It does not adapt to fit existing models. It simply remains, unchanged, while the explanations around it begin to thin. At first, the process is methodical. Known phenomena are revisited with more precision. Exotic astrophysical events are considered, not dismissed, but explored to their limits. Could this be an extreme variation of something we already understand? A rare alignment of conditions producing an unusual effect? Each possibility is examined carefully, not with speculation, but with data. And yet, something subtle begins to happen. The explanations start to feel less like solutions and more like approximations. They do not fully describe the behavior of the signal. They only partially resemble it. Each model captures a fragment, a hint, a shadow of what is being observed, but never the whole. It is as if the language of physics, precise and powerful as it is, begins to lose its ability to fully articulate what is happening. That loss is not immediate. It emerges slowly, through repetition. The same calculations are run under different assumptions. The same frameworks are adjusted, expanded, reinterpreted, but the outcome remains incomplete. The signal continues to exist just beyond the reach of any single explanation, not far outside it, but close enough to expose its limitations. This is where the tension deepens, because science is built on the ability to describe reality with clarity, to translate observation into equations, to reduce complexity into understandable patterns. But what happens when the phenomenon resists that translation? When it cannot be fully expressed within the existing language, no matter how refined that language becomes? The instinct is to push further, to refine the models again, to search for a missing piece that will bring everything into alignment. But with each iteration, the gap does not close. It becomes more defined, and that definition changes the nature of the problem. It is no longer about finding the correct explanation within the current system. It begins to feel like the system itself may not be equipped to describe what is being observed, not because it is flawed, but because it was never designed to account for something like this. That realization introduces a quiet but profound shift, because if the signal cannot be fully described using known principles, then it exists at the edge of what those principles can explain. It marks a boundary, not of knowledge, but of language, a point where our ability to describe reality begins to weaken, even as our ability to observe it remains strong. And in that space, uncertainty takes on a different form. It is no longer the uncertainty of not knowing enough. It is the uncertainty of not having the right tools to know in the first place. This is where the conversation changes, even if no one states it directly. Because once physics reaches the edge of its descriptive power, the next step is not just deeper analysis, it is expansion. A search for new ways to think, new ways to model, new ways to interpret what lies beyond the current framework. But that step is not simple. It requires letting go of the assumption that every phenomenon can be understood using the same set of rules. It requires accepting that there may be aspects of reality that do not fit neatly into the structures we have built, no matter how accurate those structures have been up to this point. And that is where the signal becomes more than an anomaly. It becomes a threshold, a point where the known begins to give way to something else, something that cannot yet be fully defined but can no longer be ignored. Because when explanation begins to fail, the only thing left is the question. And the question is becoming harder to contain. The uncomfortable territory, intelligence without identity. There is a boundary science approaches carefully, almost instinctively avoiding it for as long as possible. Not because it lacks evidence, but because of what it implies. That boundary is the idea of intelligence, not as we recognize it, not as something with a face, a voice, or a civilization, but as a pattern that reveals itself without announcing its origin. Up to this point, every effort has been made to keep the signal within the domain of natural phenomena, not out of fear, but out of discipline. The history of science is filled with moments where unfamiliar patterns were eventually explained through mechanisms that required no intention, no awareness, only the consistent behavior of matter and energy. That precedent creates a kind of restraint, a refusal to move too quickly toward conclusions that cannot be verified. But something about this signal resists that restraint. It is not simply that it repeats, it is how it repeats. The structure does not drift. The variations do not dissolve into randomness. Instead, they seem to preserve a kind of internal coherence, a stability that feels less like a byproduct of natural processes and more like the result of something maintaining itself over time. This is where the discomfort deepens, because coherence, when it persists beyond what randomness can sustain, begins to resemble something else. Not intention in the human sense, not purpose as we define it, but a form of order that does not emerge easily from chaos. It suggests a process that is not only active, but consistent in a way that is difficult to attribute to known forces alone. No one claims it is a message. That would be too simple, too immediate, too tied to our own expectations. Instead, the question takes a different shape. What if this is a form of intelligence that does not communicate in ways we recognize? Not through symbols or language, not through signals designed to be decoded, but through structure itself. Through repetition that is not meant to be read, but simply exists as it is, embedded in the fabric of reality without explanation. This idea is difficult to accept because it challenges the way we define intelligence. We tend to associate it with form, with identity, with systems that resemble our own. We imagine civilizations, technologies, intentions that mirror human thought. But the universe does not require those assumptions to produce complexity. What if intelligence, in its most abstract form, does not need a body or a location or even a beginning in the way we understand it? What if it is something that can exist as a pattern, a process that sustains itself across space and time without ever needing to declare its presence? The signal does not answer these questions. It does something more unsettling. It makes them unavoidable, because once the possibility is considered, even briefly, it changes the way the signal is perceived. It is no longer just a phenomenon to be explained. It becomes something that may be expressing a form of order that lies outside the categories we have created. And that is where the tension reaches a new level. Because if this is not just a natural occurrence, but something that reflects a deeper structure, then the implications extend far beyond the signal itself. They reach into the nature of reality, into the assumptions we have made about what can and cannot exist. This is not a conclusion. It is a threshold, a point where the question is no longer about identifying the signal, but about redefining the concepts we use to interpret it. And once that process begins, it does not move backward, because the possibility, once seen, does not disappear. It remains, quietly reshaping the way every future observation will be understood. The mirror effect. Why this changes us. At a certain point, the signal stops being something distant. It is no longer just a phenomenon unfolding somewhere beyond the reach of our bodies, in the cold silence between stars. It begins to move inward, not physically, but conceptually. It starts to affect the way we see ourselves in relation to everything else. Because the universe we believed we understood was not just an external reality. It was a framework that gave us orientation. It told us where we stood, what we could know, and how far our understanding could extend. It gave us a sense of position, even in a cosmos that has no center. The signal disturbs that position, not by providing answers, but by introducing a level of uncertainty that touches something deeper than knowledge. It touches identity. Because if the universe behaves in ways we cannot fully interpret, then our place within it becomes less defined, less anchored to the assumptions we have relied on. For a long time, we have lived with a quiet idea, one that shaped our relationship with the cosmos. The idea that, while vast and often indifferent, the universe is ultimately silent in a meaningful way. That beyond the signals we detect, beyond the radiation and the light, there is no deeper layer of interaction, no response, no reflection. But the presence of this signal challenges that silence, not by speaking, not by delivering a message, but by existing in a way that feels incompatible with the expectation of randomness. It introduces the possibility that what we have interpreted as silence may not be absence, but limitation, a boundary of perception rather than a boundary of reality. That possibility changes the perspective, because if the universe is not entirely silent, then our role within it is not as isolated as we once believed. It suggests that observation may not be a one-directional act, that the act of looking outward might be part of a larger interaction we do not yet understand. This is where the reflection begins. We start to question not just the signal, but ourselves, the tools we use, the assumptions we carry, the definitions we rely on to separate what is natural from what is meaningful. And in doing so, we begin to see how much of our understanding is shaped not only by what is out there, but by how we are structured to interpret it. The signal becomes a mirror, not because it reflects us directly, but because it exposes the limits of our perception. It reveals how much of reality is filtered through models that, until now, have worked well enough to feel complete. It shows that what we consider to be the full picture may only be a portion of something larger, something that does not fully align with our expectations. This realization is not dramatic. It is quiet. It does not arrive with certainty, but with a gradual shift in perspective. A recognition that the universe may be more complex than our frameworks can capture, not in scale, but in nature. That what we have defined as reality may be only one layer among many. And once that idea takes hold, even slightly, it begins to change everything. Because it alters the way we interpret not only this signal, but every signal, every observation, every attempt to understand what lies beyond our immediate reach. The universe is no longer just something we study. It becomes something that, in a subtle and difficult-to-define way, challenges us in return. The silent conclusion: the universe is watching back. At the beginning, the direction was clear. We looked outward. Telescopes extended our senses beyond the limits of our bodies. Instruments translated distant light into data. Every discovery followed the same pattern. We observed, we interpreted, we expanded our understanding. The universe was something to be explored, something that revealed itself piece by piece as our tools improved. There was a quiet assumption beneath all of it. That observation moved in one direction, from the universe to us. The signal changes that, not by proving anything directly, but by introducing a possibility that was never fully considered. That the act of observing might not be as isolated as it seems. That what we detect is not only a passive reflection of distant events, but part of a larger dynamic we do not yet understand. The signal does not behave like a random emission. It does not degrade, does not scatter, does not dissolve into the background. It remains stable, present, almost as if it exists in a state that is independent of the conditions that should influence it. That independence is what creates the unease, because it suggests that the signal is not simply passing through the universe. It appears to exist with a kind of persistence that feels detached from the environment around it. And when something appears detached from its environment, the question naturally follows: is it being sustained? That question is not answered. It is not even confirmed. But it remains, quietly shaping the way the signal is perceived. Because if something is sustained, then it is not just a product of initial conditions. It implies continuity, a process that does not fade, that does not collapse into entropy in the way natural systems typically do. And that is where the perspective shifts again. Because once continuity is considered, the signal is no longer just a moment. It becomes something ongoing, something that exists not only in the past, but in the present, something that continues, regardless of whether we are observing it or not. This is the point where the direction of the question begins to change. We started by asking what the signal is. Then we asked how it behaves. Then whether our understanding is sufficient to explain it. But now something else begins to emerge. What if the signal is not only something we are detecting? What if it is something that, in a way we cannot yet define, exists within a system that includes us? This is not about intention in the way we understand it. It is not about messages or communication as we imagine them. It is about the possibility that the universe is not entirely passive in relation to observation, that there may be structures, processes, or patterns that exist in a way that intersects with our act of looking. The signal does not confirm this, but it makes it impossible to ignore, because once the idea enters the frame, even as a distant possibility, it changes the meaning of observation itself. It suggests that what we detect might not be entirely separate from the act of detecting it, that the boundary between observer and observed may not be as fixed as we have always assumed. And that is where the silence becomes different. It is no longer the absence of response. It becomes something else. Something that feels less like emptiness and more like distance. Not distance in space, but distance in understanding. A gap between what is happening and what we are capable of interpreting. The signal remains within that gap, unchanged, unresolved, present. And perhaps that is the most unsettling part. Because the universe has not suddenly become louder. It has simply revealed that its silence may not mean what we thought it did. Maybe the question was never whether we would find something out there, but whether something out there was waiting to be found. The silent conclusion. The universe is watching back. At the beginning, everything felt distant. The signal was just data, a pattern appearing on a screen, something abstract, disconnected from our lives. It existed far beyond us, somewhere in the cold vastness between stars, carried across unimaginable distances before reaching the fragile instruments we built to listen. It felt safe that way, because distance creates comfort. It allows us to observe without being affected, to study without feeling involved. The universe was out there, and we were here, separate, defined, secure in the idea that no matter how strange the cosmos became, it remained something external to us. But that separation begins to dissolve. Not suddenly, not in a dramatic moment, but gradually, as the implications of the signal unfold. Because the more we analyze it, the more it refuses to behave like something that simply passed through space. It does not fade. It does not scatter. It does not lose coherence in the way every other known signal eventually does. It persists, and persistence changes perception. Because when something remains stable across time and distance, it no longer feels like a transient event. It feels present, not just something that happened, but something that continues to exist, independent of when or how we observe it. That subtle shift carries weight, because it suggests that the signal is not just a trace of the past. It is something that, in a way we do not yet understand, still exists in the present. And if it exists in the present, then our act of observing it becomes part of a larger context. We are no longer just receiving, we are participating. This is where the unease deepens, because participation implies connection, not necessarily communication, not intention, but a relationship between observer and phenomenon that is more complex than simple detection. It suggests that the boundary we have always assumed between ourselves and the universe may not be as rigid as we believed. The signal does not confirm this idea, but it does something more powerful. It removes the certainty that it cannot be true. And once that certainty is gone, the perspective changes in a way that is difficult to reverse. The universe is no longer just a stage where events unfold independently of us. It becomes something that, at least in part, intersects with our presence in ways we do not fully comprehend. This does not make the universe smaller. It makes it deeper, because it introduces layers of interaction that are not immediately visible, patterns that do not reveal their meaning easily, processes that exist without explanation. It suggests that what we perceive as silence may not be emptiness, but complexity beyond our current ability to interpret. The signal remains within that complexity, unresolved, unexplained, unchanged, and that is what makes it so powerful, because it does not give us answers. It gives us a shift in how we see the universe, how we define observation, how we understand our place within everything that exists. It forces us to confront the possibility that the cosmos is not just something we explore, but something that, in a subtle and profound way, reflects back on us. Not with intention as we understand it, but with presence. And that presence changes the meaning of everything that came before. Because the question is no longer just about the signal. It is about what the signal reveals, about the limits of our understanding, about the boundaries we thought were fixed, about the silence we assumed was empty. And once those boundaries begin to move, even slightly, there is no simple way to return to the certainty we once had. Because now, when we look into the universe, we are no longer certain that we are only looking outward.